All right, so this session is all about idempotency for mere mortals like me, that sometimes you have an architect that tells you, do this thing once and only once. And it looks super easy on an architecture diagram. In practice, how many people know how to implement idempotency? How many people can implement idempotency in 10 seconds? Maybe tonight. Maybe tonight. So I'm Heitor, Lessa, I'm a chief architect for a product called Powertools for AWS. And I only have 2 slides. I'm going to try something new today. And especially because it's the first time I'm speaking at SLSDays after 9 years of serverless. So thank you, Pete. Thank you, organizers, for having me. If you don't know about Powertools, we started with observability, trying to solve tracer, metrics, and logging for mere mortals like all of us. And eventually, customers wanted to do more, and the community grew. And eventually, without even realizing, 40% or more of everything we have came from customers. So we started with observability. We went down batch processing, feature flags, event routing. And 2 weeks ago, we just announced encryption, data masking in just 1 line or 2 if you need. And now it's all about idempotency. That's all I have for slides. So now, hopefully, the demo gods will be on my side. And we'll just use code and nothing else. And maybe we start from scratch. So let's see how much I can do. My hands are a bit shaking, so let's actually get into that. It's a bit odd to code by standing up. What we're going to do is to start with a simple transaction to show you why side effects are complicated and why implementing idempotency is something you want. Then we implement idempotency, go through multiple states, and we go from very simple to complex, 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 complex. Cool? Okay, so I'm going to use the best language in the world called Python, but cool, I have your attention now. That's good. That's what I wanted. See? And let's get started. So the first thing we're going to do is let's maybe say refund an order. So an order is going to be a dictionary, and that could be a hash map in other languages and such. So all we're going to do is to maybe have something like a refund ID, and then we could return something actually unique, so it helps us to see if something is idempotent or not. Let me know if you can see at the back. So I'm going to try to zoom in as much as I can. Thank you. See, this is already getting help, so I'm feeling more relaxed now. So maybe the status, we're going to say refunded, something really simple, nothing complicated. And then we're going to say refund order, and we're going to pass an order. And an order, maybe let's just say that the order has a payment ID, and we just generate a UID. Maybe we say the same thing for, let's say, customer ID, if you like. There we go. And let me just generate a UID real quick. Cool. Maybe let's start with that, and then eventually we can add other things. So this should be more than enough. And then let me just print it, just to see if this thing works and my IDE works as expected. Nothing complicated at the moment. So if I try to zoom in, I'm not sure if I zoom in, can you see it? Cool. Thanks. So you can see that we have a UID, and if we try this one more time, we should see different IDs coming up on the screen. So now we have something that maybe we just went bankrupt because we refunded so many times the same customer for so much of our money that we shouldn't do. That's one of the challenges of side effects. Ideally, we want to refund once, and if you're lucky, if you're building something new, a new system, you want to take that into account. If you're building something new, maybe you don't need this feature because you already took the time to implement everything in idempotent ways and handle side effects and whatnot. But reality is not everyone builds something new every day. Right? You have something that you may not touch. Maybe whoever built it left, and now you're dealing with, how do I touch this thing? Cool, I can see some shaking heads. That's the reality we live in. Cool. But how do you do this now without knowing too much about idempotency and without breaking the whole application? So that's what we're going to do now. So the first thing we need to do in Powertools is something that we call idempotency config. So once we import this thing, we have to say where in our payload it's something that should be unique. If the request comes multiple times, what exactly should be unique? Payment ID, for instance, we can start with that. So if we start with this, that should be enough for now. We will go more complex as we go. The next thing we need to store this somewhere because we're going to be dealing with Lambda functions. So multiple Lambda functions could be spun up at a time as is chaos. So I can't rely in memory all the time. I could use in memory, but I have to have somewhere. So one of the things we can do is to have a DynamoDB persistence. If I can only type DynamoDB persistence layer. That's where I'm getting a little bit nervous now. We're going to use a table called SLSDays, which are already deployed just for safety. If everything goes down the drain, I have DynamoDB local. It also works. So maybe let's do it this way. So that's what we need for now. The next thing we need is we need to change this function to have a decorator. It works the exact same way in TypeScript, Java, and .NET. We're going to import this thing here, and we're going to pass the configuration. We're going to pass the persistence storage. And because we have a function that could have multiple parameters, at the moment we only have order, we have to say which parameter in my function the payload is going to come in. The reason for this is I could have something like metadata, and I could have something else. It would be a bad idea to hash everything because some of the parameters could change. I only want this order, and inside the order, I only want the payment ID. So let's try this now and see if that still works. It worked. If you can see it here, ignore the warning. In fact, let's just ignore the warning now. So that doesn't really get into you. Let's user warning. There we go. Let's try this one more time. OK, the red line is not there anymore. If I try to zoom in, you see that the number is C0. That's EUID, remember? If I try run multiple times, I still see C0. To prove this is actually idempotent and my function is not being executed, maybe let's just try to raise an error. If I try to do this now, it still works. That's how idempotent, that's the talk. Thank you very much for coming. Now, this is just a simple example. OK, so that's how you get idempotency pretty quickly, and it works, and how I trust the product and Powertools to make everyone's life easier, one at a time. If I go and see the DynamoDB table now, what I'm going to see is I have some of the DynamoDB patterns, which you can see if you like reading the source code. We implement 100% of all the serverless best practices in software in Powertools today. You can get the whole well-architected in 1 hour today in Python. Other languages are still progressing on that one. What we have is the name of the Lambda function. What is the name of the file name? You could have app.py, test.py, whatever, but we're using IDE. And then the name of the method or function, whatever you decorated. So if you have the same file name, the same function, or some forth, we make sure this is unique. And the payment ID that you saw earlier, we hash the content of payment ID, and we turn into an idempotency key. So if the same payload comes again, we go to Dynamo, fetch it, that's it. But now we need to also serialize the response, so we can return the exact same thing as it is. But Dynamo can get expensive if you have something like this. So we have measures to counter all of these things as well. One of the things we do is we add expiration. So as soon as we store this idempotent, this transaction by default should be valid for 1 hour, but you can go even further, fine-grained to this. And we have different status to make sure that we know if something is in progress, completed, so we can handle unhappy paths. If this is actually just a normal idempotency, I will be lying to you. There's a lot more complexity to do idempotency. So let me show you how this works in practice now. So let's just get rid of this so it doesn't fail my thing. I'm going to change the payment ID now so we can show you what happens when idempotency is at play. At the moment, we have the order that we just created. That's the transaction. Payment ID is different. If I go to DynamoDB now, you see that we have a request in progress. This hasn't completed yet. So once this is completed, ideally I should have the data in here. But I already know what is the payment ID hash. So I already calculated these things. So if I try to do complete this thing and run this again, then you see this transaction has been completed. So that's the state you should know. In progress, completed. Still with me? OK. Nice. Let me get my cheat sheet. So now we already covered a simple transaction. We tried. You had the states. In reality, in legacy systems, you're not going to only have payment ID. Maybe you also want to have something more unique, payment ID and customer ID, or whatever else you want. What we can do is we use JMSPath, or is a JSON query language, where you can simply do this. And now, once we run this again, it will now be idempotent. And the hash now, it's hard to see in here, but you see it changed. It's going to be different because we're now hashing both customer ID and payment ID, and you can add multiple fields at a time, so you make it more resilient. Still with me? Cool. Now, this is the happy days. When something goes wrong, we're actually going to see some of these pieces now. For instance, let's say one of the first issues. So one of them is to say, what if the request fails halfway through? So I'm going to try to simulate this by simply enabling the debugger and stopping the debugger. So now I had the request flying in. Imagine API gateway, just invoke a Lambda function, or a queue, just process the message. And now we have is in progress. If I stop this debugger, she simulates that something happened. You had unhandled exception or whatever. If I query the DynamoDB, it's in a dirty state now. It's in progress. I have nothing in here. There's no data for me, right? So if I try to execute this again, we're now going to have an error. This could be good and bad. The good idea is that if you have multiple requests coming in and you're still processing, another request comes in, you're going to be in trouble now. It could be a different inconsistent state. So we only allow one request at a time, the exact same parameters. So we're going to fail subsequent ones until you do something about it. The problem with this, though, is what if your function timed out? Now it's going to take you an hour for the next request to be successful. Luckily, in Powertools, we have a great community, and we thought about almost all the possible things that could go wrong. What we could do here is let me just do here. We could simulate a Lambda function locally. Let me just create a Lambda context. I don't need any of these things. Where all I'm going to need to do from a Lambda function point of view is I need to know how long it's going to take before the function times out. So that every Lambda function has a context object, which you can check how long it's going to take. This is great for batch processing, long running, and whatnot. So we take advantage of that information. And what we do is we can say, in the configuration, we can say, registered this Lambda context. So we're going to do this. And if I'm going to change this slightly payload, because now it's going to continue to fail until I delete this record. So if I try this again, you're going to see a slight different changes in the structure of DynamoDB. And this will grow even more complex, but we'll get there one at a time. There's a new field now in DynamoDB, but we also do the same in Redis and whatnot. You can even bring your own persistent storage if you like. This in progress expiration is when there's a potential issue where it timed out or a request failed halfway through. The next request that comes in, we're going to be looking at this expiration now. So if this is still expired, we go and try a new request. So let me stop this now, so you know it's true. I hope it is, yes. And if I try this again, it now works. It doesn't have any errors in here. If I try one more time, now it's idempotent, and we have a new completed. What was in progress is now completed. So we go back and fix the orphan record that we didn't know what was happening. So we can fix these timeout issues and so forth. Cool. So now we got into this already. We got the request failed halfway through, the timeouts, concurrent request, and such. But legacy can get even more tricky because it could be years someone is developing this. This is still very simple. For instance, what if someone says you have a field that the amount that you need to refund is 100 euros or 100 Australian dollars. If I try and call this now multiple times, I'm actually refunding only 100 euros. But someone could figure out that you're taking the customer ID and the payment ID as a dependency token. So imagine your system does something, even though it retries the same, maybe it doesn't handle this correctly. What you can do in idempotency is to say, if someone tries to steal your request, a middleman attack, for instance, halfway through, is I want to look into the payload, the field called amount. Even if a request is idempotent, if someone took the exact same request and changed that little bit only, we should fail. So I'm going to make this, change this one more time. And I'm going to keep as 100 euros now. What you're going to see in the DynamoDB table now, there's a new field called validation. So we do the hash of the amount key. So if that changes, if we change it now, say we want 100,000. Why not? And you see that we actually fail. Even if the request has been already validated and idempotent, we should fail this request. And to not make this call over and over and over to DynamoDB, because, well, we could get a little bit expensive, if I'm honest, you could say use local cache, and then we're going to use that in memory now. So it goes a little bit faster. You see what I'm going with this? You go one thing at a time, and this can go over and over. I haven't checked my time, so I think it's still good. This is great when you're doing some of the batch processing async works, but what if you have an API, a REST API, and you need to return to the client that this request is idempotent? That will be a little bit more tricky to do this now. You need to know the details of DynamoDB and also the idempotency engineering side of things. Thanks to Michael, who's also here in the audience. He helped contribute a feature that I wanted to have it for so long. One of the things we can do is to have a hook function. It doesn't matter the name of the function. So let's say we need to have the response of the idempotent request that we already transact, and the idempotent record that is stored in whatever persistent storage, DynamoDB, Redis, you name it, right? So we're going to call this data record. And because we know we are only returning a dictionary, we could just type as dict. So what we could do with this thing here is just say x idempotent expired. Let's put it this way for now. And in this record that we know, we could say maybe it is expired already or not, because we already control this thing, okay? Because this is a response hook, I need to return a response. So if I just go and return this response now, nothing's going to change. What will change is we can say response hook is this function right here. Remember, this request was already idempotent. I think I removed, let me just go back to 100, otherwise you will fail validation. If I try this now, what you see, this response that initially was only refund ID and status now has a idempotent expired. So I can manipulate this thing and return to my client now, do whatever I please. Does that kind of still make sense? Okay. So that's kind of what you do. Thank you, Michael, for this feature. I appreciate it very much. But if you're building a legacy system, especially if it's been 10, 20 years, there's one piece that's missing, and it's going to break your application if you do something like this. Most of the time, you're going to have a data transfer object, or a DTO, if you like, right? So you're not going to have a dictionary flying around without any types, without anything. So typically, you're going to have, in Python at least, you're going to have, let's put this, a class called refund, and we can take refund ID as a string, and this as a string. So now we can take this now, and let me just put this real quick. And this should be, yeah, if I can type real quick. And this should be a string. You see, I'm getting slightly nervous now at the end, but I'll get there, I promise. Okay, so now we do this. If we try to do this in idempotency now, because the request is the same, that should be okay. But if I try to call this now, the challenge with this, if you haven't noticed, is that this is now a dictionary. Because in the persistent storage, we need to serialize this thing into JSON and store this there so we can do the reverse, deserialize and respond the exact same thing. But the challenge of this is that I could have an application right here, another function, anything in my source code that I might want to have .refund ID. So if I try to do this, this technically should fail because there's no attribute in the dictionary, it's a hash map. So if you're thinking of contract testing, that should fail right there. So how do we solve this? Luckily, we do have a solution for this. What you could do is inside your configuration for idempotency, let me just use spaces so it's easier to see. You can bring your own sort of a serialization. Actually, it's not even here. This is supposed to be in the right here. We have an output serializer, which we can send the response before it goes, and we can serialize, deserialize, whatever we please. Because in Python, it's very common to have this type of data class or pydantic or whatever. We already have this in place. So if I try to do this now, let me just actually go back in here and do a debug. Oops, something failed. Hang on. Let me try again with a different payment ID. Oh, I had a debugger. Okay. Sometimes it can happen, right? You can see that this is no longer a hash map. It's actually a native object in Python that we actually did as before. So my code, if I were supposed to try and debug this now, I don't know what's going on here. In the debug, this should no longer be an issue because now I'm actually returning that as we go. I know what the issue is now, not just thinking. This is no longer a dictionary. This is now a refund class. So I'm going to have to move this back so my IDE doesn't complain. That's why I was complaining too. We cannot try to change this attribute as a dictionary because it's no longer a dictionary. This is actually a real object now. In fact, I can even access it now. So I have to do something else. Let's say maybe X idempotent expired, and I can pass the exact same thing. It's not refund, it's response. You're supposed to be helping me on this typo insertions. Okay. So let's see if that works now. I'm going to try another non-idempotent transaction. I'm going to stop this and work and see if it works. It works as is. If I try to do a debug now, that's about the problem. Okay. So if I zoom in now, inside this response, I have this refund object and I have refund ID that was added before, but the response hook added this for me, and we know that this is actually not expired. This is an actual idempotent request that we should send something to the client. So this allows us to make all these changes without changing anything in our legacy code or existing code, and we can do as we please. I could go on in even more things in idempotency, but what I will do now, conscious of time, is, I have a lot more time, actually. I could even build another application. I'm kidding, I'm not going to do it. In Powertools, we have a lot more stuff. The same experience that you saw in Powertools, add this one line and keep adding configurations one at a time. We have this for everything else, from tracer, logger, metrics. If you use Datadog as well, switching from CloudWatch to Datadog and vice versa is also online. If you want to do REST APIs, GraphQL APIs, if you want to switch from API gateway REST to HTTP, to VPC lattice, to Lambda function URL, you name it, it's going to be also online, but we keep the same experience. If you want to use GraphQL or GenAI, you can also do GenAI with the same experience. Maybe if you want to fetch something, for instance, I will show you another example. It's not related to this. If you want to get a parameter from parameter store, you could just do this. I don't know, name of my parameter if you like. Or if you want to set a parameter, what do you think it is? Set parameter. Maybe if you want to cache this now, to say 100 seconds or more, we will cache this for you as well. If you want to get a secret, can you guess what it is? Get secret. Exactly. So if I try to do get secret, and Powertools has this feature all over the place. We know how you use these things traditionally, and then how you can do this in Lambda later. So if I wanted to do an API, for instance, I would also have something like this. I would create a new API like this. Actually, it's not like this. And I can simply say now to my Lambda lift, or a micro function if you like, and say last to do. And I could have something like my to do. Actually, let's make it as a post. Create to do as an example. And we're going to return a to do. And then you do whatever to do you want to do. And in your Lambda function, all you need to do in Powertools, it's going to be this: app, resolve, event, context. We do all the writing, all the data validation for you, open API spec, Swagger UI with this. What happens in Powertools is like set pieces. It's like Lego blocks. You add one feature at a time, and you just keep going and going. If you want to do, let me just get rid of all of this. Something we announced last week. It was so hard. It took 50 hours just to write the documentation, and 6 months just to get to the UX. Say you want to have a secret information you want to encrypt. All you need to know is symmetric encryption, asymmetric encryption, and a bunch of other pieces. It's easy. Piece of cake. The same way idempotency was also a piece of cake in PowerPoint presentations. Implementation is a completely different beast. So what we could do, completely not related to the session, because we finished earlier, why not? We can do just this, and I can say, for instance, remember the order that we have. We could have address, for instance. And then we can have something else, I don't know, city, for now. And what we could do with this new feature we just announced is if I want to get rid of all this data, for instance, I could just print this now. Oh, because I haven't installed the dependencies. That's why I wasn't supposed to be doing this. But the point is that I can simply erase and pass the data that I want, but I could also pass the fields. I could pass address.city. And if I want to encrypt, you might guess already how I should be doing it, encrypt order. If I want to decrypt, I could pass decrypt order. Maybe if I want to use multiple keys, I just pass a list of keys. If I want to use multiple regions, I pass a list of keys of multiple regions. That's Powertools. I hope you like it. If you need more information and you need a link, because I forgot the link, you can go to powertools.aws.dev, where we have more information. And that's idempotency for mere mortals. Let them retry now your existing systems. Thanks for having me.
Awesome. Thanks, Heitor. All righty. Oh, I have no idea what you just said. Anyway.